I will show you a stepper for very common Lisp. I have built this initial version for this stepper in order to improve ABCL because I really enjoyed the implementation. I've been contributing to it. And I think this tool can help ABCL users and common Lisp users in general. And also because I needed something like this for my personal projects using ABCL. And after I found that other options out there were somehow difficult to integrate, this is a public source code. It is public as a pull request to ABCL source code repository in GitHub, and it is implemented as a country for now, following some suggestions from ABCL maintainers. Before I started the implementation, I found mainly two approaches to start with the implementation. The first one is instrument the code, an approach used by SBCL and Slice Stepper projects. And the second approach is integrate the stepper with the current evaluator in the implementation, an approach followed by projects like Lisp and ECL. The main advantage of the first approach, implementing the code, it is that it can work even with compiled code, because you can instrument the code while compiling. But the main disadvantage is the complexity around this instrumentation. The second approach, on the other hand, the main advantage is its simplicity, because it only needs integrate with the evaluator, and the evaluator will be handle the stepper inside. It will be simpler. But the main disadvantage is that it won't work with compiled code, and this is because ABCL's current code evaluator, it is an interpreter, and it is not entering into compiled code. The compiled code is executed as Java bytecode, and so for this reason, our stepper it won't work with compiled code. But I think it's not a huge limitation, because in common Lisp, interpreted code and compiled code should behave almost the same regarding results. But also because I think the simplicity it's quite important. I mean, these factors made me chose this approach to start with the implementation of this stepper. As you can see, we have a summary of the architecture of the stepper. It's quite simple. I have added some code in a way of hooks inside the ABCL current core evaluator, and also some internal states, mostly flags. And according to the values of the internal state, the stepper will be going back to the evaluator without any stepper, or actually it will be handled stepping. Let's see with more detail in the code. I have here in this source code, we can see this class, a Java class called Lisp, that contains many core components in ABCL. And the evaluator is inside this method. And what I did was adding some code here in a couple of stages of the evaluator. The first one is here when we are analyzing a list expression, and the first element is a special operator. Here there are code related to the stepper. According to the value of this function, this component, we will be handling the stepping code in this method, and also in the call to this method called eval call. There are also some code related to the stepper. I inserted code in this method, which is basically being called when the first element is is a function, it's a Lisp function. The internal states of the stepper are these attributes. The first one is the most important because it is determining if we are stepping or not. The second one is related to the next feature. This one is for the quit feature. And the last one is counter for the number of the steps. The validation function, the component that determines if we will be stepping or not at the current point of the evaluation. It is this method, basically, which does some simple logic, but delegates the core logic to this function in Lisp. So inside Java, we are calling Lisp. This function called stepping symbol, almost the same name. Is in this file called ABCL stepper lisp.lisp. So this is the function. It is receiving the function value, the Lisp expression, and this parameter, this attribute value of this attribute related to the next feature that we will see later. And according to this information, it will be deciding if we need to step or not at this point. There is also the handler function, which has also both a Java side and a Lisp side. It is this method, which is invoked, of course, after the validation function result is positive. Here it is, as you can see, it is doing some validation and some operations, but the main code, it's also delegated to these two functions in the Lisp side. This function prints forms a step, which is printing the preamble to the user. And the second function, handler user interaction, as the name indicates, it is handling the user interaction when we are stepping. Let's see it in Lisp. So this one, it is printing like a preamble to the user. And the second function is called handle user interaction. Is this one. And as you can see, according to the input from the user, it will be deciding what to do in the current stepping session. I will show you now some examples for illustrate the use of the stepper. In the first example, we will see the feature step, inspect, and continue. The feature step is the most basic operation in the stepper. Inspect allows us to retrieve the values of local variables, and continue. And the continue feature will allow us to complete the evaluation, turning off the stepper. Let's see it. I have this shell, this Lisp REPL loaded in an Emacs shell for some convenience, but it is almost the same comparing with the console, with the console in Linux, or the console in general. In Windows, you can run ABCL in Windows or Mac, as it is based on Java. And also I have loaded this initialization code in this REPL, the module ASDF to load ASDF systems. This module that allows us to load contrips and this stepper contrib, and this one to load quick list systems. Going back to the shell, I will be using some code from this file for the examples. For this first example, I'll be defining this global variable called Zamora. this function called test, and let's step into it. As you can see, we are seeing 4 lines. The first one is, in general, they are informative to the user. The first one is indicating that we are in the stepping mode. This will be the counter for the stepper, showing us the value of the current stepper as a counter. This is the current form we are stepping. And this is a visual hint showing us that if we type the keyword interrogation, we will see a little summary of the options of the stepper as a minimal help. And for this example, let's first use inspect. At this point, we can type the keyword I, and then the next of the variable we want to step. In this case, some bar. As you can see, it has the value 1. And now, with the keyword else, we can step into the function, step more and more. At this point, we can also inspect again the value for the variable some bar. As you can see, now it changed. Now some bar has nil as a value because the let here changed the variable to nil. It changed the binding for the variable. We can also inspect the symbol x. As you can see, it has 3. And if we type C, the keyword C for continue, we will be completing the evaluation without any more stepping. As you can see, all the enumerated steps got its corresponding values. In this case, all were the same on the final value. Let's see now another example. This example will show us how to get all the local values of the variables in the current environment. I'll be using this code. As you can see, we have some lexical values here, so lexical variables, and also functional functions, lexical functions. One lexical function called flet1. If we step into the function and type the keyword L, we will see the list of the bindings into blocks, one for variables and the second for functions. In this case, at this point of the stepping process, we can see that A has a value 1 and flet1 has its functional value. If you step more, you will see after typing L, you can see 2 values for the variable A, and this is because we are showing the values from inner to outer scopes. In this case, the inner let is assigning 2 to the variable A, and of course the function flet1, it has the same value. So at this point we can type continue, and to avoid any more stepping, the remaining stepping, and complete the evaluation with the final value, in this case 8. For the first example, I will show you the feature next and quit. This example will be a little bit more involved. For this example, I'll be creating a package called step next, and inside that package, I'll be creating these functions, defining these functions: loop 1, loop 2, loop 3, and test next. Well, the feature next is a way to specify breakpoints in symbols related to functions. I mean, if we use the keyword n, it will be stopping only in calls to functions with symbols that are marked, tagged to be used with the feature next. This can be made in more than one way. the first way is by pushing the symbols to this list called stepper stop symbols. In this case, we will be pushing the symbol loop1 related to the function loop1, that's with the same name. And the second way is pushing symbols designating packages to the list stepper stop packages. That list will that way we can we are telling to the stepper that that it needs to stop in the exported symbols in all of these packages included in this list. In this case, we will be exporting loop3 and pushing the current package a step next to the list in stepper extra packages. That way we are telling to the stepper to stop in loop3, in the call to the function loop3, when you insert the feature next. Let's see it in action. If we call text next in the stepper, and if we type next, you will see that it is stopping in the call to the function loop1, because we added loop1 to the list in stepper stop symbols. If we type next again, it will be stopping in the function loop3, skipping the function, the call to the function loop2. And it is because loop3 was exported and the package was added to the function, to the list in stepper stop packages. And at this point, I can also explain the feature quit. The feature quit allows us to avoid the remaining operations in the stepping process, in the evaluation in general, and returning nil. This is useful to when we want to abort the stepping and the evaluation to avoid costly operations. In this case, I have this assignation creating a huge list to this variable. So I'll be typing the feature quit with the keyword Q, and it will be returning nil. And we can check that this assignation was never made by using this assert. As you can see, there were no issues because that assignation was never made by the use of the feature quit. Going back to the next feature again, let's call again the stepper on the same function, same call. And we can manipulate also these breakpoints by using the features B and R. B for adding breakpoint, dynamically both using in the middle of the stepping session. If we type the keyword B and we insert a symbol, we will be adding a breakpoint. In this case, we will be adding a breakpoint for the symbol loop2. And at the same time, let's remove a breakpoint to the symbol loop1. Basically, what this operation are doing is manipulate the list in the stepper stop symbols. And now, if we type next, you will see that now it is stopping in loop 2 and not in loop 1 because that were the operation we just did. And again, we can type next, it will be stopping in loop 3, and we can type Q again to abort the remaining step. Okay, let's see quickly another examples. The feature show backtrace, which allows see the backtrace. If we call the function, this function I just created with the stepper for speed up the things, I will put the breakpoints at the symbol plus. And if we use next, we will be in this point of the calling the function f3. If we type bt, we will see the current backtrace at this point of the stepping process. And well, let's type continue to complete the evaluation. For this fifth example, let's see the feature watch variable. It's a feature that allows us to follow the variables for variables we want to see in the stepping execution, and it's helpful to avoid calling, the inspect feature or the local feature all the time and only follow the interesting variables. In this case, let's step into this function, stepper um, step and test watch. And with the keyword W, we can type the variable we want to watch, in this case X. As you can see, there is no value for now. But if we step more into the function, you will see that eventually it will get the value, and it will be showing the successive values the variable is getting. At any point, we can unwatch any variable being watched, in this case X, and we can step without seeing the value for the variable. For the final example, I'll be showing how to use the stepper with AESDF systems. For this example, I'll be loading Alexandria with quick Lisp. Let's load Alexandria. If we try to step into, let's say, the function lerp inside Alexandria, you will see that there were almost no stepping, and that's because our stepper is not designed to step into compiled function, and that's the usual way when we load an SDF system. But if we have the alternative to use the operation load source up, and that way we will be getting almost all the time interpreted code. And let's step into the function now. As you can see, we can now get a step into the code because it's now an interpreted function, and use all the features we have in the stepper. So yeah, let's tape continue again to complete the evaluation. So this is the stepper. It's the initial version. I think it's usable, even knowing that it is a first version. Of course, there are a lot of things to improve. I want to make it work without blocking other threads, which is the current version. It would be better to make it non-blocking for example, for production code. I did it in this way because I got some nasty race condition, but I think it can be it can work in a non-blocking version. Of course, the integration with the Slime and Slide, it is important because these tools are quite useful for the Lisp community, and of course add more features that steppers are out there normally have, like for example a step out, a step next, evaluate arbitrary expressions in the stepper. So I'll be working on it. This is the code. You are invited to contribute, and I'll be happy to answer any of your questions. Thank you.